Saxon Algebra 2, Lesson 47. Greetings, students. This is the next to last lesson for the fall study period. Look, ready to be impressed with yourself? I'm impressed with you. Look at how many lessons we have done. That is a lot of lessons. That is 13 unrelenting weeks of hard work, and I'm very proud of you. I'm going to be checking this one off because I'm teaching it to you now. One more to go before we wrap up with our midterm and our Christmas break. So get pumped. We're getting close to a break. Lesson 47 has two lovely algebra components. So let me start with the first one. It's on unit conversions. Now, forget about the word rate for right now. Unit conversions. We've been doing these for a while now, and we've had kind of a progression. First, we did conversions of length. Those were the basic ones. Remember, a length is like a piece of rope or a piece of string, right? Where you're just measuring how long it is. And they happen in one dimension. So when we were using our conversion factors or our unit multipliers, whichever you'd like to call them, we only had to use one, right? As opposed to our second ones where we were converting area. Area has two dimensions, right? We would be converting like a piece of paper or a piece of cloth or a farmer's field, something that has a length and a width. There are two dimensions. And we had to remember to use each unit multiplier twice because first we'd convert one dimension and then the other. Thirdly, we did volumes. That's three-dimensional. I have to draw a cute little cube. I remember so clearly the day I learned to draw three-dimensional cubes in my grade school art class. I was very excited. 3 dimensions, 3 ways to measure it, right? Length times width times depth, however you want to name those. There's a dimension this way, a dimension this way, and a dimension that way. So we have to use each multiplier 3 times, right? In order to convert all 3 of those dimensions. We also, along the way, as we've dabbled in this, we've talked about the English units, which are, for example, feet, inches, yards, miles, right? Those are some examples of English units that we've used. We've also talked about the metric units. And those are things like millimeters, that just looks like a mess, doesn't it? It's supposed to stand for millimeters, meters, kilometers, right? Not to mention the other ones like liters. So we've talked about converting these 3 different types of conversions in 2 different ways of measuring them. All right, so we've already covered a lot of information about unit conversions. Today we're going to learn rate conversions. Now, like any time we talk about rate conversion, a rate is always equal to distance divided by time. Everyone knows that cars travel at a rate that we measure in miles per hour, right? That's how our speedometers are set up. But there are lots of other ways to measure rates. For example, when we're talking about space travel, I don't know about air travel, but I know that any form of space travel is measured in feet per second. Feet is the distance, time is the second. But what I want you also to notice about these rate calculations that we'll be doing today is that they're a fraction. We've never done that before. We've always just done one thing at a time, right? These are fractions, which makes them honestly kind of fun. So we'll do that in just a second. We may use, I'm just glancing ahead, it looks like we're mostly going to use English units rather than the metric system in the examples that John gave us today. But you can use metrics too. It doesn't affect this or make it harder in any way, shape, or form. So let's try example 47.1. It says, use unit multipliers to convert 42 inches per second. We write the rate as a fraction. Convert it to miles per hour. So just like we've done with all of our rate conversions, start by writing what you have, write the ending units down at the end. Now, what do we do about this? This is a hot mess. What we do is first we convert the numerator and then we'll worry about the denominator, okay? So always do the numerator first. Inches to miles. All right, let's take it on, shall we? Now the nice thing is we don't have to worry about 2-dimension or 3-dimension. This is just a 1-dimensional adjustment, a 1-dimensional measure, so that makes life better. We want to change these inches into miles, but we're going to have to go through and change them into feet first, right? I do not know how many inches are in a mile. I know there are 5,280 feet in a mile, so we're going to go on what we know. All right, so this is my thinking, right? I want to go from inches to feet. I write my kind of my map down here is what I think of, and here we're adjusting the top. All right, with these two. So inches, I want to put inches down here so they'll cancel. I want to change it into feet. I know that feet are bigger, so I give that the 1. How many inches in a foot? 12. Okay, so I've changed from inches to feet. Now I'm ready to go from feet to miles. So I'm going to put feet on the bottom, miles on the top. A mile is bigger, so that gets the 1. This gets, oh, I'm going to have to squish, 5280 feet. I hope you can read that. Now I can see that my feet cancel. That sounds weird. And I'm in miles, which is exactly where I want to be. Yay, I'm half done. Our numerator has been successfully converted from inches to miles, and there are the numbers that help me do it. However, we now have to work on seconds. And what I can see right off the bat is that to go from seconds to hours, the logical way to do it is 2 steps. Again, we're going to go from seconds to minutes. I'm writing kind of tiny, I hope you can see. And then from minutes to hours. This will be to adjust the bottom. Numerator, denominator. We don't need to use fancy words if there's any chance that it's just going to make us write longer, whatever. Top and bottom tells us exactly what we need to know. Okay, so now I'm ignoring all of this and I'm just paying attention to the second. I'm using the same rules that we use for creating these conversion factors or unit multipliers, whichever you'd like to call them, but we kind of have to think upside down. So in this first box, I want to go from seconds to minutes. Seconds are on the bottom, so that means I'm going to need seconds to be on the top so I can cancel them. Since I want to go from seconds to minutes, this is going to have to be the minutes on the bottom. See how I have to just reverse my thinking? The concept's the same. I want the unit to cancel and the new unit to carry on, but the way that I do that has gone upside down. Okay, what's bigger, a minute or a second? Yes, I hear you, 1 minute. And there are 60 seconds in a minute. Seconds now have canceled. We're stated in minutes. Now our second box for the denominator is going to take us from minutes to hours. Again, I want to cancel the minutes, so I put this up here. Hours will be down here. An hour's bigger, so it gets the 1. There are 60 minutes in an hour, so that gets the 60. Minutes cancel. I'm left with an hour in the denominator, and look, that's exactly what I want, an hour in the denominator. Woo, what a workout, right? That's a lot of thinking, and we had to turn our brains upside down halfway through. I hope it didn't hurt you, but now we're ready to collect up our numbers and summarize our answer. All right, our answer is 42 times 60, and I'm gonna do 60 squared because we see two 60s right there, over 12 times 5280, and that's all. Those are just ones. This is our final answer, and then we put the unit on it, miles per hour. Those are our ending rates. You can use multiplication dots, or you can use parentheses. You can use the exponent to show multiple factors, or you can write them out. You can put in the ones. Sometimes John goes crazy on those ones and he adds them all to the answer. But multiplying 1 times anything is nothing, right? It doesn't change the answer. So you can leave the ones out. I'm perfectly fine with that. This, I'm just making sure. Dun, 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 dun. This is the perfect answer. Yay. All right, so that gives you a hint on how rate unit conversions work. They're super important in the sciences. Like I mentioned, physics, aeronautical engineering, there are astronomy, there are lots of different scientific fields where rate unit conversions are a fact of everyday life. So when you study those subjects, you will have the fond pleasure of doing this. Okay, let's do another one. There are 3 of these, and then we switch topics. Use unit multipliers to convert 480 miles per hour to feet per second. Okay, we set it up. If you like to put this beginning number over a 1 just to keep everything super clear, I'm fine with that. It's absolutely fine. We have to now figure out how to go from miles to feet and then from hours to seconds. We always take on the numerator first. So the good news is I think we can get from miles to feet in 1 jump, don't you? This time we don't need any stepping stones in the river. We can leap clear from one bank to the other because we have the number we need to go from miles to feet. Miles is in the top, so I want to put it down here so it'll cancel. Feet, again, we're working in the first dimension, so we don't have to do any squares or cubes of anything. That's what makes this nice. A mile's bigger, 5,280 feet in a mile. And now the miles cancel, and we're working in feet, and that's exactly where we want to be. Hallelujah. All right, now let's start working on the denominator. We need to go from hours to seconds. So, okay, this will be hours to minutes. And then in the next box, we'll go from minutes to seconds. And that will get us there, right? Okay, let's do it. Now we have to think upside down because we're in the denominator. Here we start with hours. We want to go to minutes. We need to put this up top so they will cancel. Oh, I'm sorry. I got excited and wanted to go all the way to seconds in a single jump. If you know the conversion factors, you can take bigger jumps, right? We could go, say, directly from hours to seconds, but I don't want to push more conversion factors into your brain, right? I don't want to have you memorize more of these numbers that link them. It's easy enough to just go in smaller steps. Hours are going to cancel, but wait, first 1 hour, 60 minutes. Now we can cancel, and we are in minutes. Okay, now we're ready to go from minutes to seconds. Minutes up here, so they cancel. Seconds down here. A minute is bigger. There are 60 of them. Cancel. We're in seconds, and look, yay, that's where we want to be. So now all we have to do, let me just do this again. This is the top, converting the numerator. This is what we did to the bottom. If you're feeling turned upside down as you're doing all of these adjustments, identify what is the top change and what is the bottom change. That'll just help your brain separate these two parts of the problem out so that you don't get scrambled up. I always recommend that you work on the top first. It's just more natural. It feels more comfortable. Converting the denominator does feel a little crazy, so save that for the end. I mean, you know, best for last, right? Okay, now we just gather up our numbers. We start with 480, and we multiply it by that one, and then these are just ones, so we don't need them, over 60 squared, and then we copy the ending unit. You can put this line in or not put this line in. It's kind of an option. I generally like to put it in because it reminds me that it's a fraction. I like to keep them separate, the words from the numbers, but I like the line. Sometimes people will leave out that line. It's not a big deal. Do it however you like it. That's the right answer. Yay. Okay, one more of these. 47.3. Oh, there was one more thing, one more point I wanted to make on this one. Sometimes it's confusing, the units. M is the abbreviation we use for meters, which is a metric unit. MI is what we use for miles. And MIN, what happened to my speaking? This is minutes. All right, so it's easy to get turned around because those three are so similar, but that will help you keep it all straight in your brain. Okay, now the third problem. Ready? Let me give you a second longer to get that copied. I know, I go too fast. I think of that almost every day when I finish. I'm like, that must be so annoying to have me going fast. And I've told this story before, but I'll tell it again. When I was in college, I had to take an insurance class. I was an accounting major in college. So I was used to classes with a lot of numbers and a lot of details. It wasn't a big deal for me. But I went to school back in the days before PowerPoint, but it kind of is like PowerPoint. Teachers used overhead projectors, and you know, they were like the clear glass with a light underneath it, and then you would put on a transparency, which was like a piece of plastic film, and then you use those special pens to write on it, right? And then you could erase it if you wanted, but it would stay on that plastic film, and you could keep the plastic films if you wanted. Well, this insurance professor had prepared these plastic films with all the notes. He didn't write as he went like I do. He had it all written out ahead of time. Probably he used it from quarter to quarter over again, so he didn't have to write out his notes. But what he would do is he would take this plastic film with just packed, as dense with text as you can imagine, handwritten with these markers. He would slap it up on the overhead projector so we could see it on the screen, and then everyone in the class would start as fast as we could. We'd all just be writing ferociously, right? Trying to capture all this information. He's talking to us. We're not listening. We're just frantically, like galloping horses, copying as fast as we could. A lot of times you didn't get to the bottom. You'd turn to the people next to you and be like, can I look at your notes later? And they'd be like, yeah, it's fine. And then he'd just slap up the next one. It was a decent class in terms of the material, but I learned so little because the whole time I was in class, I was just trying to frantically write. And I always think of that. Now you've had more than enough time to write this because I've been ranting and telling you a story. It's easier to listen to stories as you write, right? As rather than me telling you the difference between, you know, whole life and term or something like that. That's insurance stuff. So I consider random stories to be easier to listen to than lectures when you're writing. Plus, you know what? Our brains need breaks. I tell random stories partly because I tell random stories, but also because it gives your brain a break. And honestly, you need it, right? Okay, no, there's one more of these. Sorry. I just want to move on to the next part so badly because I really like the next part. My light is making a glare. Let me see if I can make it go away a little bit. I need a lighting technician to come and save me from myself. Okay, that's not so glary. I hope you can see okay. I think it's decent. Now it's shining in my eyes. It's okay. I can handle it. 47.3, here comes another one, ready? Use unit multipliers to convert 15 inches per second to yards per hour. Okay, so just like the other ones, it's a distance over a time. I can put that over a 1 if it helps me. And now we're going to figure out first our roadmap for how to get from inches per second to yards per hour. Now, I said before, and I'll say it again, if you're a crackerjack, you may be able to quickly figure out how many inches are in a yard. 12 inches in a foot, 3 feet in a yard, that's 36. If that's in your brain, it's perfectly fine to use that number to get you directly from inches to yards, but I'm gonna play dumb because, not that it's dumb, but I'm gonna just do it the more detailed way. So you can take shortcuts if you feel confident with them, but I'm not gonna push that onto you. I'm gonna just give it to you slow and steady. So to get from inches to yards, we're gonna do it in 2 steps. Here are my 2 boxes. Remember, we don't need to do 2 or 3 dimensions. This is all 1 dimensional. Here, I'm going to go from inches to feet, and then here I'll go from feet to yards, and that will be how I convert the top. Now, to go from seconds to hours, again, you could probably pretty easily figure out a conversion factor that lets you go directly from seconds to hours, but I'm going to do it the slow and steady way. We're going to go from seconds to minutes, and then we'll go from minutes to hours. This will be how I convert the bottom. Again, numerator, denominator, let's keep it simple. All right, so we carry on. Inches, this tells me what I'm trying to accomplish in this box. I'm starting with inches, so inches go on the bottom. Feet go up here. Feet are bigger, 3 inches in a foot. Boom, boom, yay. Now we're going from feet to yards. Feet down here, so it'll cancel. Yards up here. A yard is bigger. There are 3 feet in a yard. Oh, look at that mistake. I also love to imagine your shocked and horrified face when I do something crazy like that, right? Because obviously I was thinking about the 3 feet in a yard, and I just wrote that down here. I love when I make these mistakes. Well, I don't. Actually, it must be frustrating for you because you must just sit there going, what? 3 inches in a foot? Wait, what? I'm glad I caught it quickly so that you don't have to be freaked out about what's happened to my brain. Okay, feet cancel. This looks better. I think I got it right. 3 feet in a yard, 12 inches in a foot. Now we've gone all the way to yards, and that's where we want to be. Sometimes I put the S, sometimes I don't. Honestly, I like it better when I don't. A lot of the abbreviations, like inches, it doesn't have an S in it or not. Like you wouldn't put INS. Feet, the plural, doesn't have an S. Yards is a little different because the abbreviation has the ending letter. So sometimes people want to put that S on there. It's up to you. I don't care. Either way is fine with me. That's a better way to say it. Now we're going to convert the bottom. We want the seconds to turn into minutes. Seconds are on the bottom, so we need seconds up here. We want to go to minutes. A minute is bigger. There are 60 seconds in a minute. Seconds cancel. Now we want to go from minutes to hours. Minutes are on the bottom, so I'm going to cancel them up there. Hour, an hour's bigger, 60 again. All right, now we can cancel the minutes, and we're in hours. Hours is another one that sometimes people put an S. It's up to you. All right, ready? We're now ready to simplify our answer. 15. Skip over the ones. Times 60. I'll write it out separately this time before I used an exponent, right? Over 12 times 3. And that gets us to yards per hour. Yay, that's the right answer. If the numbers are simple enough, you could reduce and multiply to get a simpler version of this answer, but that's not important to me. What's more important to me is that you understand the sequence of how you're making the changes and that you get all of your units and your multiplier numbers in the right place. So if you can create this answer, I'm not that worried about you simplifying it. Honestly, I know you can do that. Okay, that's all I need to say about rate unit conversions. We've added another quiver to our conversion strategies arrows, and like I said, these rate unit conversions get used all the time in sciences. Let's talk some about fractional exponents. When I first learned fractional exponents, I was disgusted. I'm like, we have pig houses. Pig houses are fantastic. Why do we need to take a perfectly good pig house, throw it out the window, and use these fussy little fractions? And I understand that. The reason why the fussy little fractions, or the fractions and the exponents are helpful is because then we can use our rules for exponents to simplify them. It's much more easy, it's possible to tinker with them and simplify them if we convert them into fractional exponents. Now, in this lesson, we are going to be exposed to, we're going to have revealed to us 2 trick situations, okay? So they're both tricky. Let me show you. Once I show you, then you're in on the trick. This is how this problem looks. Okay, now, when you look at this, you think, okay, we turn pig houses into parentheses, and we could do that, and we'd end up having something like this. We'd have 27 to the 1/3 times 3 to the, it would be the 1/6. You can just trust me on that. But we would end up with the 2 different bases, right? And then we would be stuck because the rules for exponents don't work unless the bases match, right? We always draw the x's. They have to match. So this, just converting this to fractional exponents without using the special trick I'm going to show you is not going to do us any good. What we have to do when we see this is we have to think to ourselves, let's see, I need to make a thought bubble. It's going to go up here. We have to think to ourselves, oh, 27 equals 3 cubed. Oh. Now look what happens. What we're going to do is we're going to rewrite this 27 as 3 cubed and see what happens. All right, I'm going to change pig houses to parentheses, and the way it's going to end up looking is we're going to have big parentheses like this. No, I want to go slow. Never mind. Let's change the little one first. It'll be square root of 3. This will still be 3 cubed, and then this will be 3 to the 1/2, right? So that's just changing this one. Then from there, we'll change the big one. So it'll be, again, pig house goes to parentheses, 3 cubed, and then 3 to the 1/2 inside. And then this is a third root, so we'll put a big 3 up there, right? Okay, now we can use the power rule because our bases match. Oh, it's so happy, isn't it? I'm going to go over here to write my answer so that I can finish going this way. This will be 3, let's see, 3 times 1/3 is going to be 1, right? So I'm going to put it as just a 1 over 1 because we might have to change that later. And then the second one, 3 to the 1/2 times 1/3 is 3 to the 1/6. Okay, and we saw that right there. That's where I did my quick jump. All right, okay. So we're doing well now. Again, we're so happy we have these matching bases because now we can add their exponents. Now we're using the product rule, right? This is the power rule. This is the product rule. Let me write those down just so you have them in front of you. The power rule says if we're raising a base to a higher exponent, if it has an exponent to a higher exponent, we multiply them. That's what we did here. That's the power rule. Now we're using the product rule, which says if you're multiplying matching bases with exponents, you can add the exponents. We use both of these. If the bases didn't match, we'd be sorry out of luck. So that's why this little trick is so important. All right, so let's change this to 6 over 6, right? So that they match. And then our final answer is 3 to the 7 over 6. Yay. If you don't mind my loopy, oh, by the way, this is no bueno. We don't want to do that. We don't want to leave that 27 in there. We want to change it to 3 cubed right away so that the bases will match and we can use our rules. Okay, let's do one more. I think there's just number 5, right? Yes. And it is a very similar, we use the same trick over again. It's not 2 different tricks. Ready? This time we're finding the 6th root. Don't let that freak you out. It doesn't matter. Okay, what's important here is that we notice right away, well, oh, the bases don't match. So we think, this is my thought bubble. This is the way I like to show this. 4 equals 2 squared. Now they'll have matching bases. This is what I want to happen in your brain. Okay, so we're going to rewrite this. We'll keep that creepy 6th root out there, but we'll write this as 2 squared and then square root of 2. Now the bases match. Yay, that's the trick part. Now it's just smooth sailing the way we're used to doing it. And again, I'll convert 1 pig house at a time. If you're feeling fresh, you know what? Go for it. You can convert 2 together as long as you're getting them right. Okay, so my inner pig house goes to parentheses. Oh no, this should be 1/2. This is a square root. It's in my next round that I'll use the 6th. All right, and then now here comes the next round. This stays 2 squared. This is 2 to the 1/2, and we're gonna use this to make the fraction over here, right? Now we're ready to use our power rule to simplify these. This will be 2 to, let's see, it'll be 2 over 6. I'm going to just leave it as 2 over 6. I might want to reduce that, but I don't know yet. And then this will become 2 to the 1 over 12, right? Again, my power rule. I know I write these over and over. I really want them to be burned deep into your brain. That sounds violent. I think of a wood burner and me like jamming it into your ear or something, which sounds painful. Let's not do that, but you know what I mean. Okay, so there's our power rule. We used it there. Now we've got matching bases being multiplied, so we're ready to use our product rule. And that means we'll add these. And we can see we're going to have to bump this up. We'll multiply it by 3 over 3 to get 3 over 6. Now we can add them. Our final answer will be 2. Oh, wait, I did something wrong. Oh, look. I just wrote 2, but it should be 12. Has that been driving you crazy? So we'll multiply this by 2 over 2. No. This one we don't need to adjust. Sorry. this one will multiply by 2 over 2. That will become 4/12, right? I'll squish it in right here. 4/12 plus that 1/12 equals 5 over 12. And hopefully you didn't get too distracted by my mistakes in copying these exponents. Isn't it funny how I do this so often where I get so excited about the next numbers that I'm going to write down that I accidentally write the new numbers into the old ones, or where, you know, they shouldn't be. Okay, 2 to the 5/12 is proper. The right answer. Now, let me just give you one caution, especially as we're coming up on the midterm. I want you to be very careful. Sometimes when students are working problems like this, they don't make their bases big enough. So then when they write their exponent that's big and messy like this one, they will write it like this. Do you see how this doesn't look like an exponent at all? This looks like a mixed number. No. You can't let your work distort the value of the numbers. Here it's clearly an exponent. Here it looks like a mixed number. Make sure your answer does not look like this. Make sure it's clearly an exponent. If I saw this on the test, I would have to take points away because that doesn't look like the right answer. Do you see what I'm saying? This fraction is too big. And I've made it really big because that's what I do. But if a student was writing it on a test, it probably would be little and squishy like that, right? It's harder to make the exponent look like an exponent. So this is a big don't do it. This is a cautionary tale right here. I'm going to put it on a puffy cloud of knowledge to remind you, do not let your exponents get big like that. Okay, guess what? I can't think of another single thing to say about fractional exponents and the importance of adjusting the bases so that they match. The problem has to be set up to let you do that. Otherwise, you'd be stuck. But anyway, John sets them up that way, and we just knock them on down. All right, lesson 47 is complete. Thank you.